Welcome to the Thoughtful Software Podcast. Innovate and thrive with thoughtful software. This podcast is all about helping technology leaders simplify innovation, build emerging tech, and confidently fuel digital initiatives. Join Andrew Wolf and Fahad Shokat as they discuss how to navigate the ever-changing software landscape. Keep it simple, focus on people, and consistently deliver value.
All right, Andrew, before the pandemic, I went to Amazon reInvent in Vegas, and I was just shocked by how many software vendors there are out there, thousands of them, selling all types of different services, microservices, lakes, containers, different products. And if you think about it, like software systems are just becoming so increasingly complicated and sophisticated, and it's being driven by a lot of the demands for new business requirements. And it was just shocking to me. I don't know how anybody makes sense of it, how to put all this stuff together, but you're probably one of the best software architects I know. So I think it's fitting that we talk today about how someone should approach these complex systems and try to demystify software architecture, because there's just a lot going on that I don't think people appreciate underneath the hood and how these systems are, actually running. And as I mentioned, the evolution of business expectations is driving a lot of the complexity. So instead of maybe discussing the specific elements of an application, maybe we can start talking about how do you start approaching these types of problems, whether it's known or unknown. Do you think about software patterns first? How far ahead are you thinking? Where do you start?
Yeah, I think this is an excellent topic. People, for whatever reason, I think people will make it more complicated than it needs to be. Just like everything in my life, I like to go back to first principles. And what I mean by that is there's a set of principles that you can use that will help guide any software architecture you're putting together. One of the things you hear me say, this is a wide shared principle, but it's one that I think is really important, which is earning your complexity. We talk about that a lot. But there's other principles that we don't talk about as much. Things like abstract that which changes. And what that means is, as you're building your architecture, you want to take and create an abstraction for things that are going to change. And you can know which is going to change if you study and understand the industry or the context you're working in. There are other great principles as well. And these principles allow us to think about the problem and not necessarily the solution. And then patterns will naturally come up. For example, there's a pattern in object-oriented programming called a factory pattern. Factory does exactly what you think it would do. It generates a lot of the same type of object. Maybe there's some configuration, some parameters that change the way the factory produces the object. But a factory pattern is very ubiquitous because, as you can imagine, in the real world and modeling a problem, there's oftentimes you have to create many of the same type of object. And this is one single pattern that you can learn to do it. But those naturally occur as you apply first principles to the problem and understand the context you're working in.
Let's talk about one thing you hit on was understanding the problem. And it's almost like gathering requirements. And you sound like a product manager there and trying to understand what you're trying to solve for. How do you put that together and working with product managers in that early stage of understanding what you're trying to build and then thinking about which one of these software patterns or what road do you want to take at that point?
Yeah, I think any good product person who understands just enough architecture to be dangerous. I think any great architect also knows enough product to be dangerous. I would never pretend that I spent my career, understanding product frameworks and how to think and do market research. I can do some of it, but not as well as a trained professional that does that. But you have to know how that works. So if you look at architecture, I'm going to take a step back. What is architecture? I've said this multiple times on this podcast, but it's a fancy word in my mind for business enablement. And whatever that business happens to be that you're working on, I'm using the word business here in the royal sense of the word, meaning your business could be open source. Your business could be solving for a system thing. Maybe it's building a cache or a database. It could actually be a business as well. But when we talk about business enablement, and how you want to do that. And if you're understanding that's what architecture is, then it's a natural extension to work with product and help them understand how this is going to be implemented and the real world consequences for implementing certain features. Software is a game of trade-offs. The ultimate trade-off is what we call time versus space. Okay. So if you want something that is real time, does things really quickly, you're going to optimize towards the time. But that means you're going to not optimize towards space. What could that mean? That means you can load all the data into RAM, into cache on the CPU, and you can do cool things like that because you're optimizing for the time. But then you're not optimizing for space. Conversely, you're not going to load a petabyte of data into RAM. Or I don't even know if there's a computer that can do that. And if there is, it's not widely available. And so you can't do that. So now you're talking about a space problem versus a time problem. And you can't, if you're going to iterate over a petabyte of data, you're going to have to do it in a distributed way or take a lot of time to do it. So again, that trade-off. A good architect is going to work with the product people that have looked at the market and know the features they're going to do, help them understand the trade-offs and the complexity they're earning into the system by implementing different features and go-to-market strategies. For example, a lot of startups, their go-to-market strategies build as many features as they humanly can, as fast as they can. And a good CTO explains to people, okay, we're going to take a lot of our, not even hypothetically, angel and seed money to build features, but then our Series A and backloaded to Series B usually, we're going to have to take that money and invest in technical debt. You're loading up the credit cards to move very quick. You're leveraging yourself, and now we need leverage. And a good CTO, good architect is constantly talking about these trade-offs and constantly informing people of doing that. A good architect also never says never or no. The answer is never no, we can't do it. There are some things that physically can't be done in today's world. I can't break encryption in my lifetime. I can't break hashing right now. In the future, when quantum computing comes out, different story. But as of today's technological restrictions, I can't do that. And so there are some things you can, but in general, with enough time and money, you can do anything. And so you're always working with them to help them understand what they can do, what options they have.
It's an interesting point you brought up around technical debt. And I'm curious, how far ahead are you thinking? Because I've seen in certain companies, they just completely disregard technical debt as just, it's a matter of fact, and we'll fix it later. You've seen a lot of companies, I think Slack at some point, I wouldn't say that they disregarded it, but at some point they knew they had to re-architect their entire system in the way for it to work better with video and voice. And so are you at that point at any stage, like thinking 2 years ahead or 3 years ahead, or are you just kind of looking at what do we need to accomplish in the next year, 6 months? Do you have a time scale as you're designing these systems?
I think you have to, but let's talk about leverage for a minute, because I think it's best to think about tech as leverage. What are you leveraging? You're leveraging your future. You're going to pay interest on whatever you have. And so let's say real world leverage, you use capital to grow your business, right? So let's say you take a loan out and it's 3% interest. If you don't grow at least 3% from that over a time period, you're losing money, right? And the same way with technical debt. You should be leveraging. You should be having technical debt. Having no technical debt shows that you're not investing anything in the future. You have a stagnant system. You constantly need technical debt because that means that you're leveraging the capabilities you have to either move fast or get what you want. And then just like that's the vehicle for growth, so is technical debt. And if you think about it that way, then you should always be looking at it as if you're the CFO of your code base. And the CFO of your code base says, okay, if I take on any more leverage, this thing's going to tip over and we have a chance of having to file bankruptcy. And that's a rewrite. And so knowing you don't want to go towards bankruptcy, but how can you leverage to get to the business what it needs and enable the business? And if you think about it that way, what's the proper way to look forward? 5-year pro formas are fucking stupid, right? I've never seen a 5-year pro forma where I thought, oh boy, they're totally going to hit this. Or maybe they do, maybe they don't. It's 5 years in the future. Pandemics happen, recessions happen, everything else happens. And the same kind of mindset has to be applied to technical debt. There's a reasonable amount of time to look forward. And you do that by looking at the product roadmap, understanding what you need to build, understand what's going to change, and work towards that and find out the proper ways to leverage yourself. anything more than probably 2 years is too much, right? If your product has a solid roadmap for 2 to 3 years, you're not looking at how the market's changing. You're not adapting to the change in the market. And that's a business problem because software should constantly be evolving and the market's constantly evolving. New competitors arise, new counter products, acquisitions happen, things like that. And so as that happens, you have to be adjusting as well. So I think there's a reasonable amount of time you have to look forward, probably at 6 months to a year, and everything after that's speculative. And you should constantly be measuring technical debt and paying down some leverage so you can leverage other places as well to enable the business in the future.
Yeah, it brings back to one of the earlier points I was making around, or questions I had around software patterns. What have you seen in your career, like, to understand what are the best patterns to think about as you're building and accumulating technical debt? Are there best practices? Because I'm curious, like, when is that trigger point? Or I know there's no marker or ever or in your roadmap that, okay, now we're going to switch to do something else because we've accumulated too much technical debt. What are you looking for that kind of helps you think about all these unknowns in the future?
So one thing that a lot of junior engineers and unfortunately senior engineers do, they think there's such thing as a best pattern. Now, there is no such thing as a best pattern as there's no such thing as a best tool, right? The hammer has a job, the screwdriver has a job, patterns have jobs. And so the patterns that you use are the best way to think about it. If I'm doing something 2 or 3 times in a code base or a system, that means that there's something repeatable there. And I need to do what's called refactoring to push that into a abstracted form of it so that I don't do it 3 different places. I do it one place and I provide the capabilities to do what it needs to do for all 3 places. And that might get refactored to a pattern or it might be refactored to a subsystem or whatever. And by doing so, you create simplicity. Your goal is to trend and refactor towards the simplest possible system, right? If you solve any big enough problem, the system will not be very simple, right? But you should be trending in that direction. You should always want to remove things, not add things, because the more things you have, that's more things you have to manage, the higher cost it's going to be, the more people you need to throw at it. So the perfect system, just like the perfect definition of an organization, it should trend towards the least amount of software possible. And so you should be refactoring your code and your architecture constantly to think about how to remove things that you don't need anymore, to simplify by removing duplicate entries, duplicate code, and all of that into common patterns. Like I said, there's things like the factory pattern, there's decorator patterns, there's strategy patterns, there's hundreds of software patterns that you can leverage, and you have to go and read about them and learn about them. In my mind, that they are fundamentals to doing your job. And so I believe everyone should learn them. They don't learn them, and I think a lot of bad code's being written because of it, but that's either here nor there. In my opinion, these patterns are good, but it's not just about those type of patterns too. There's types of refactoring patterns. Martin Fowler has a book, it's a famous one on refactoring. It's his seminal work, in my opinion. And I think it lays out like 30 or something refactoring patterns. The code smell to tell you when to refactor, how to refactor that particular thing, and how to test and everything else.
I would say one of the things I was thinking about is as you're refactoring, that kind of tells me that it's not like an all or nothing proposition or solution, right? It's you can refactor, you can make adjustments, you can move along and think about the changes that are happening. Because a lot of the sometimes technical executives that we talk to, it's almost let's make a decision now, and this is the path that we're going forward. And it's a huge discussion, numerous meetings on what's the architecture going to look like. Is that the case, or can you walk back or make adjustments if you made the incorrect decision in the beginning?
I think thought up front is good. I think it's General Patton that said that he would create battle plans and then he'd get to the battle and throw them out immediately. And I think that's probably the best way to describe it is you should create a battle plan. You should have a general direction, and then you should throw your plan out because no good plan lives getting punched in the face. And the reality is going to punch you in the face as you try to build a system. In that way, yes, planning is important, but you should also be able to think on your feet. Don't spend too much time planning because things do change, things evolve. You learn things as you go. And so there's amazing patterns that are known as evolutionary architecture patterns. A while back, I think it's one of the most bullshit things anyone's ever said to me. Someone once told me like, oh, the architecture is emergent. You're going to figure out what the architecture is over time. That's partially true. Architecture does evolve, but if you put no thought into it, like why are we picking a SQL database versus a non-SQL database? Why are we using this type of caching, first in, first out, or anything else, these cache expiration strategies? What type of cache are you using? How are we deploying the system? Are we using Docker to abstract the operating system? Are we deploying to Kubernetes? If you're not thinking about those things up front, you're in for a fucking world of hurt. It's just not good. There is move fast, break things sometimes, proof of concepts, but on production applications, that kind of lazy thinking and non-upfront, work is hurting your team and your company. But at the end of the day, there are things that you can put in place, patterns, evolutionary architecture patterns that help you either change a wrong decision or quickly fix things and evolve. And so you want to use a combination of evolutionary architecture choices and also some upfront thinking to really help guide you along the way. I think about strategy versus tactics. You almost want to separate the two. That's why there's architects and there's principal engineers. The engineers are going to be the people on the ground getting shot at, telling you, dude, I don't know what the hell you were thinking when you put this diagram together. And the architects are staying on the strategy level, talking about these are the system choices, this is why, and adjusting it on the holistic strategy rather than the tactical part of implementing it. And having those two separated, if you can be a huge boon to software systems, because very frequently the strategic direction is directionally correct, but the actual tactics to get there are going to be wildly different than the architecture things. And usually architectures haven't touched code in a long time. In my experience, I code because I think you have to. I think you should be able to do both sides, but most don't. So you really don't want them handling the tactics.
It's interesting. You bring up strategy, and what I'm hearing is that as a software architect, it's a very technical job, but how much time do you spend on explaining your strategy and talking to stakeholders, so maybe a CTO or technology leaders, to really understand, like, here's the decisions that you're making? It's almost like you're counseling that things are going to be okay. Like, yes, we don't know this. Here's how we're moving forward. How much of that comes into play in what you do as an architect?
At I forget where I read this, but every significantly high position at any company or job becomes a sales job eventually. Architect's not even in sales, right? Like
Yeah.
you have to sell your architecture, sell your ideas, sell your vision of what the system can be and why you're making your choices. There's not a day that goes by that you shouldn't be trying to, quote, close a deal on your architecture, right? Because even the engineers, when something goes wrong, they're going to lose faith that you made the right choice. Every engineer is going to have their favorite technology and wonder why we didn't pick Django and we went with Rails, or why we're using Java and we're not using JavaScript. And have you seen this hot new framework out there? And we're fucking, .com, PHP style. Like, you're always going to have this. You constantly have to be selling people and saying, yeah, that's hot, that's cool, we might use that in the next project, but hey, we need robustness here, we need to do this, and constantly selling why you made your choices. I don't believe where you're beyond reproach when you're an architect, and you need to be able to take criticism, because sometimes that criticism is wildly good and helps you form better opinions. And yes, it's a sales job. 10% of your job is diagrams, man. If you're worth your salt, the diagrams shouldn't take you very long to build, and you should just then be selling out and collecting ideas and basically going to market.
Yeah, that's fascinating. How much of this also includes like standards and governance? Is there such thing as you're building these systems around how to maybe, obviously you want to document as much as possible, but once you've laid out this strategy, how to maintain good standards, how to keep building the right systems, communicating to others, how do you keep this all together?
Yeah, it's an excellent question. So when I look at that, so I'll give you an example from my past about how architecture radically changes when you're under compliance. And I think that this will help fuel the answer to this. When I was at Diebold, we had to build a mobile banking solution for a credit card processor out of Minneapolis. And so what we did was, because we had to use what's called a PAN, a personal account number, and that's what is PCI DSS scope, we needed to have the entire thing under PCI DSS. People said, no way, that's going to cost way too much to set the environments up. We're not going to do it. So we had to go back to the drawing board and figure out how to reduce the PCI scope to the limited number of systems in this environment as possible. So what we did was this was pre-Stripe. So I always joke that we created Stripe and Stripe just copied us, but I don't have $89 billion in valuation. So there you go. But we created a box that would encrypt the PAN and store the PAN there, and then return you a token. And that token would allow you to pass that token around and still uniquely identify that user without having to have access to the credit card number. And then that same system that held the token to PAN mapping would also host a system that talked to the payment processor. Between those two systems, ultimately what happens is then that one system, it becomes the gateway and becomes PCI compliant. And every other system now only uses the token. And so in that way, we architected and encapsulated the PCI scope to one box, and the other 7 boxes, databases, and everything else didn't have to be in PCI scope. And so that's a long way and a big story to tell you that when you're dealing with compliance, you can oftentimes abstract away the compliance and the other parts of this to save yourself money, to save yourself time, to save yourself hassle, and everything else. And for example, on HIPAA, if you deal with anonymized data instead of the actual patient data, the health data, you don't fall under HIPAA scope. And so you can isolate and then also get what you need. It can be difficult in some ways, right? Some systems end up being holistically under scope no matter what you do. So there's no sense doing it. But architecture plays a big component to how compliance works and everything. So architects also, not only do you have to know a little bit of product, you also have to know about legal and compliance and all that stuff too. It's a tough job.
Yeah, that's interesting. Let's take a different point of view because let's take it because you brought up money. And so I started thinking about the people that write the checks, right? The CFO and CEO. And imagine if they're listening to you and they're like, what the heck are you talking about? And what do I do about this? Maybe the CIO and the CTO could buy into your strategy, and they're also helping define the strategy. If you're from like a business person's perspective, what are some of the things that you can say or you can provide to them that would help them understand whether they're being sold a bunch of bullshit, or because obviously the decisions you make today will change the cost of the rollout, the development, how many developers you might need, what you may need to fix later. Are there things that they can identify and look for, or is it just you have to trust the technical people?
Nah, I think that's a bullshit thing. Everyone wants to feel like they're the best, but like the best doctor helps you understand and own your health. And so in that way, the best architects are going to help the CFO, the CIO, the CEO, and all the non-technical folk understand the decisions being made and why they're being made, and puts them into a readable, digestible, I guess, piece of work, right? If they don't understand what they're investing in, then you'll never have true buy-in. If your doctor says, hey, I need you to run 5 miles a day, and you say, why? You say, just trust me, bro. You're not going to do it. You might do it for a day. You might do it for 2 days, but you're not going to do it long term. If they said, hey, if you run 5 hours a day and it's going to add 10 years to your life, now you understand a little bit more why they're asking you to do it. They're helping you own it. And ownership requires a lack of ignorance in the entire process. So if you want people to really believe in the plan, you need to evangelize it and you need to sell them and let them know why, right? If you don't, you're going to end up in a world of hurt. And the best technology leaders understand this, that it's our job to educate as well. We're in a deeply technical field where there is a lot of bullshit thrown around. Your job is not to be a bullshit artist. It's to say, this is what it is. This is why it is. Here are all the alternative proof points of what we looked at, and sell the plan just like you would as a competitive analysis. Part of your job, again, is marketing and sales. Why should you buy us? The answer can't be because I'm in the room right now. It has to be, we have this unique differentiator. This is how we're going to do better than our competitors, and let the market decide. And in this case, the market is the executives.
And it's surprising to hear, I think over the course of our time at Skip List, and just working with clients, it doesn't necessarily come down to whether you're deploying containers or microservices and lakes and meshes or whatever. It really, we've talked a lot about on this podcast about culture and people and explaining things and doing things simple, getting buy-in. And it often it's nothing really about technology. You could be talking about anything, marketing, sales, finance. It's really just about connecting and trying to help people. And that's really, it's amazing. Just when we're talking about software architecture, the first thing you said is business enablement. Like, what is the business trying to do? And that includes everybody.
Yeah, and there's a couple of things here that I think are super important. First off, there are legitimate patterns and architecture practices that simply will not work, right? Using a centralized architecture in a decentralized company, trying to do a decentralized job will not work long term. I don't care who you are. I don't care what you think you can do or how brave or smart or pick your favorite adjective you are. But if you do the right architecture, then the problem is not about what you picked. Now it's about buy-in and implementation. Implementation is done by people, and people need to know why they're doing stuff. Any technology executive, any executive in general, any manager even, knows that there's a rider and an elephant problem. You're the rider. Your logical side of you knows what's best for you, right? It knows you shouldn't eat candy. It knows you shouldn't buy that coffee that costs $6. And it also knows that those shoes that are $100 are also bullshit. But the elephant is a fucking elephant, and it's your emotions. You'll want to buy the shoes. You're going to eat the chocolate. You're going to buy the $6 coffee because your elephant wants to do it. And so when you have that kind of problem, the change management and helping people take their elephant to the end line is 90% of the job. Again, it's sales. How do I help these people see that this is really good? Logically, they'll know it's really good, but how do I emotionally let them know it's good and that they're safe now and everything else? Technology gets a really bad rap because it automates people's jobs away. And so if you're saying, I'm going to install this app that's going to make you 30% more efficient, a lot of people here, we're going to lay off 30% of people. And the sad part is they're usually not wrong. It's just how things are. And that's unfortunate. And so you have a huge elephant problem. And so, yeah, the job is, yes, 10% having the technical knowledge and being able to do it, putting in the thought. But once that thought's there, the first initial planning is done, the rest of it is the elephant problem and taking it to the finish line. And that's going to involve people, all the people spending money on it, the people investing in it, the people using it across the board, no doubt in my mind.
Are you seeing anything in the industry that you're excited about that's kind of helping break down these problems and make just understanding these complex systems easier? I know there's a lot of companies thinking about AI can, spin up environments and things like that. I get that part, but do you see anything else that is interesting and exciting to you in this area?
Besides what we're working on? No, the thing is, it's hard to solve people problems. Process, talent, doing all of that dance. It's hard to. If you could solve people problems, you could get rid of salespeople, talent agents, concierge services at airports. The list goes on. If you can get rid of people-to-people engagement, you could do that. The only way you can really get rid of it is to aid it, right? And help people communicate better. Give a common dictionary and domain language, create common reporting, do all of that. Because it's such a people problem, then it's really difficult. Again, any architect worth their salt can put together a system. If you gave me a problem, I bet I can come up with a very competent architecture, and we'll call it the 80-20 rule, where I don't understand the 20% of the pitfalls we didn't discuss, but within a couple hours, and be in the 80-20 and 80-20 problem. I'm going to ask questions about the pitfalls and the gotchas and the edge cases and things like that. The thing, though, is how I'm going to convince you that I actually understood your problem enough that the 3 hours I took to put this together, that I picked the right technologies and do all that, right? 90% of the job is justifying to you that I picked the right things, that I actually understood the problem, and that these are rational decisions, not me pulling shit out the air and no one gets fired for picking AWS, right? Like that kind of mindset. And so I think the way you do it is the tools that help convince people that people are making the right decision and build trust in your organization around the technology and around the architecture and everything else. And that's part of what the thoughtful software platform that we're building is. It's a big component around that social trust aspect that needs to be built into it. And again, I think people are tangentially dancing around this problem. And I think there's not a lot of software talent in the world to begin with, but there's even fewer people, as you mentioned, that can put all this together. And there's even fewer people that have the social skills and the EQ to realize that this is a people problem, not a technology problem.
Thanks for listening. You can always connect with us at skiplist.com.